Hello everyone, welcome to Unacademy World. Crack UPSC CSE with Unacademy. We are India's largest learning platform. Everyone knows that. Also, we have got the best educators for UPSC CSE. You know the names, you know the photographs. So guys, Unacademy subscription for Plus and Iconic, you can use YT UPSC code and get 10% off. Also, there is a combo subscription offer available for Plus and Iconic. Use the same code and get 10% off. So Unacademy optional subscription, you can actually see, you can avail 10% discount over here as well. So you can note down everything. You have to use YT UPSC as your code. Also, November extension offer, crack UPSC CSE with extended benefits, 9 months plus 2 months free, 12 months plus 3 months free. So you can avail these offers. You can use the code RUPSC, right? You can avail the offers, use RUPSC all in capitals. All right. Also, the ultimate batch for UPSC CSE bilingual 2023, November 10th onwards. You know the faces, you know the results. So please come and join. Don't let CSAT block your selection in UPSC. That is really true. CSAT has been the major block. 70% of the students, I believe, are not able to clear CSAT. Yes, this is my belief. So guys, please take CSAT classes seriously. The batches are available. Best educators are available. So why to wait? Kindly join the batches. So IAS officer revealed. This is IAS officer Mr. Gaurav Budania for a day, guys. You know this, November 13th, 11 a.m. So guys, please get started with EMI options as well. These are available. So you note down the number 8585858585 and avail EMI options. So guys, myself Rishi Bhargava, and from today onwards, I'm going to teach you CSAT, and that also in English as a language. So probably you would realize that you need expertise for aptitude, reasoning and data interpretation. So this is one of my expertise areas, and mental ability, reasoning and data. I have been teaching for the past 10 years, and I hope that you're gonna enjoy these classes. So my Telegram link, please join me at Rishi Sir UPSC, and you can follow me in the community Bhargava Rish. All right. So let's crack CSAT. So I am on Let's Crack UPSC. So I have named this class as Let's Crack CSAT, right? So CSAT, yes, it is tough, and probably you would realize that they have been actually talking a lot about numbers. So I am starting numbers as a topic, and I am going to give you good 10 classes on numbers where we are going to discuss the basics, right? We are going to discuss number rules, divisibility rules. We are going to discuss unit digits. So you can make a note of all these things. We are going to discuss a lot of formula based questions, right? Also, we are going to discuss number of zeros. That has been their favorite for number of zeros. Yes, for past 2-3 years they have been putting a lot of questions on number of zeros. And similarly, we are also going to talk about prime numbers. So everything, whatever I'm going to give you over here for numbers as a topic, is specifically for UPSC CSAT as a paper. So I hope you're going to enjoy it. I hope you're going to love it. So numbers. Today I'm going to discuss something really relevant, divisibility rules. And remainders. Divisibility rules plus remainders. This has been a hot topic for past 3-4 years. Every year a question would come from this topic. So we are going to look into all the methods, look into all the shortcuts. So welcome to the CSAT class, guys. Let's start. So first is what is divisibility rule of 2? So what I mean to say is, how do you know a given number is divisible by 2? How do you know a given number is divisible by 2? Definitely the number is even. It's an even number. So even number is exactly divisible by 2. And whenever, if you divide any number by 2, whenever you divide a number by 2, your possible remainders are 0 and 1. So when a number leaves remainder 0, it's going to be an even number, and when a number leaves remainder 1, it's going to be an odd number. So that's a good definition for even and odd numbers as well. First of all, even and odd numbers are categories of natural numbers, right? So guys, what are natural numbers? Numbers 1, 2, 3, 4, 5 and till infinity, all counting numbers are called natural numbers. So I've seen some videos where 0 is categorized as an even number. No, 0 is not an even number. Please keep this thing in mind. Why? Because even and odd numbers are categories of natural numbers, and natural number does not have 0 as a component, right? So how a number is exactly divisible by 2? It's an even number. And if a number leaves remainder 1, it's an odd number when divided by 2, right? So I think this is fair and this is even. So second, divisibility rule of 3. And I think these are few things that we remember since our childhood. Divisibility rule of 3, basically everyone is going to say, sir, sum of the digits is a multiple of 3. That is what we have learned in school, isn't it? So I say, for example, so first of all, I'm going to write it. Sum of the digits is a multiple of 3. Sum of the digits is a multiple of 3. This is what we know, isn't it? So I say, for example, I say 3721569. Is this number divisible by 3 or not? So you don't need to divide this number by 3. You just need to sum the digits. That is what you guys do. So see, this is what most of the students would do. 3 plus 7 is 10, plus 2 is 12, plus 1 is 13, plus 5 18, plus 6 24, plus 9 is 33. So the sum comes out to be 33, which means this number is exactly divisible by 3. Exactly divisible. This number is exactly divisible by 3. So genuinely this is what we know, right? And similarly, the best part is this rule also gives us remainder. For example, if I say what would be the remainder when 3721569 is divided by 3. Again, once you add it, so I have just appended 2 over here. So this comes out to be 35. The sum comes out to be 35, and 35, 3 plus 5 is 8. 8 when divided by 3, remainder is 2. So 2 would be the remainder. So now the brilliant thing about this is, please don't make a 2-digit number or a 3-digit number. See, once you add the digits, make it a single digit number. 3 plus 3 is 6. So a single digit number, when you get a single digit number, that is a multiple of 3. So single digit number multiple of 3 are 3, 6 and 9. So either you get a 3 or a 6 or a 9, then the number is exactly divisible by 3. Otherwise, any other number can be used as remainder, which means a single digit number was 8. When I divided it by 3, I got my remainder to be 2, right? So it works both ways, right? And all of you know this, isn't it? But then I give you a question. I say, if you believe in this rule, then could you please solve this question? Can you find me the remainder? So I say, what is the remainder when 9, 8, 7, 3, 1, 5, 4, 6, 9, 3, 2, 7, 8, 1, 1, 5, 3, 2, 7, 9, 9, 8, 1, 3, 0, 0, 7, 8, 3, 1, 5, 6, 3, 2, 1, 1, 7, 9, 6 is divided by 3. I can assure you, none of you are going to add now, isn't it? Because actually the rule itself is wrong, isn't it? The rule itself is wrong. Now you may say, sir, how do you say you just wrote down a rule and you say it is wrong? Yes, it is wrong. Why it is wrong is something now we need to discuss. Guys, why are you actually just adding? Right? Why are you just adding? I would say, suppose this is a number given to you. You have to check whether this number is divisible by 3 or not. My logic is ignore multiples of 3. 3 is a multiple of 3, ignore 7 plus 3, just a minute. 3 is a multiple of 3, ignore 7 plus 2 is 9, a multiple of 3, ignore 1 plus 5 is 6, a multiple of 3, ignore 6 is a multiple of 3, ignore 9 is a multiple of 3, ignore. If you ignore the whole number, the number is exactly divisible by 3. Got it? And if, for example, the second question was 3, 7, 2, 1, 5, 6, 9, 2. Is this number divisible by 3 or not? So 3 multiple of 3, ignore 7 plus 2 is 9, a multiple of 3, ignore 1 plus 5 is 6, a multiple of 3, ignore 6, a multiple of 3, ignore 9, a multiple of 3, ignore remainder 2. So if the number is fully ignored, it's exactly divisible by 3. Otherwise, it leaves remainder. That's it. Now, so now let's talk about the question above, guys. I say 9 is a multiple of 3, ignore 8 plus 7 is 15, a multiple of 3, ignore 3 is a multiple of 3, ignore 1 plus 5 is 6, a multiple of 3, ignore 6 is a multiple of 3, ignore 9 is a multiple of 3, ignore 3 is a multiple of 3, ignore 4 plus 2 is 6, a multiple of 3, ignore 7 plus 8 is 15, a multiple of 3, ignore 1 plus 5 is 6, multiple of 3, ignore 3 is a multiple of 3, ignore. See how easy it is now. And 1 plus 2 is a multiple of 3, ignore 9 is a multiple of 3, ignore 9, ignore 7 plus 8, ignore 3, ignore 7 plus 8, ignore 3, ignore. Right, 1 plus 5 ignore, 6 ignore, 3 ignore, 1 and 2 ignore, 1 plus 2 is 3 ignore, and 1 and 1 and 7. 1 plus 1 plus 7 is 9, ignore. 9 is a multiple of 3, ignore. 6 is a multiple of 3, ignore. The whole number is ignored. This number is exactly divisible by 3. Good enough, right? So this is a better rule for divisibility, right? You write down any number, right? I'm giving you one more example. So I say like 1, 1, 3, 2, 1, 5, 6, 7, 8, 1, 1, 3, 1, 1, 7, 9, 3, 2, 1. Is this number exactly divisible by 3? Ignore multiples of 3. Now listen, 3 is a multiple of 3, ignore 1 plus 2 is 3, a multiple of 3, ignore 5 plus 1 is 6, a multiple of 3, ignore 6, a multiple of 3, ignore 7 plus 8 is 15, a multiple of 3, ignore 1 plus 1 plus 1, 3, multiple of 3, ignore 3 is a multiple of 3, ignore 1 plus 1 plus 7 is 9, a multiple of 3, ignore 9 is a multiple of 3, ignore 3 is a multiple of 3, ignore 2 plus 1 is 3, multiple of 3, ignore. By luck, I have written a multiple of 3 again, right? And whatsoever number I write on a board, suppose I write any number on a board, the probability of it being a multiple of 3 is 1 by 3. Because every third number is a multiple of 3, right? So I hope now you have got a insight that you just don't need to add, just need to ignore. So remember, I'm writing the new rule. Ignore multiples of 3 and ignorance is a bliss. Remember that ignorance is a bliss. So keep this thing in mind, guys. So you got a new divisibility rule of 3 today, right? So I hope this is exciting. So if you have made a note of it, I hope that you are understanding it. So let's talk about divisibility rule of 4. Rule of 4. Divisibility rule of 4. Now I think most of you know this rule as well. The last two digits of a number are exactly divisible by 4. The last two digits of the number are exactly divisible by 4, or they are zeros. So if a number ends with 2 zeros, it is exactly divisible by 4. Right. So for example, I say 7900. Is this number divisible by 4? Yes, it is, because it is ending with 2 zeros, right? So I can write this as 79 into 10 into 10. What is 10? 79 into 2 into 5 into 2 into 5. Yes, it is divisible by 4. It is divisible by 4. So any number that is ending with 2 zeros is exactly divisible by 4. That is true, right? Now what about this last 2 digits? Which means, guys, I write down any abrupt number 5979 and 39371516. Is this number divisible by 4? Then you don't need to actually check the whole number, right? You just check the last 2 digits. Last 2 digits are 16. Last 2 digits are 16, which means this number is exactly divisible by 4. You just don't need to divide the whole number. No, not required. And then, you know, it may occur to you why. See, the most important part over here is why. So why this is so, I would just write down something. I would write down table of 4, and probably, you know, that would be really good for you to understand. Listen, multiples of 4, or I write down multiples of 4. So see, what do I do is I start writing the multiples of 4. So 04, 08, right, and 12, 16, 20, 24, 28, 32, goes on like this, goes on like this. So I'm writing the last few is 88, 92, 96, 100. 100, I'm not writing 100 as a full number, I'm writing last 2 zeros. Then 104 is 04, 108 is 08, 112 is 12, 16, 20. So it keeps on repeating. So somebody made an observation that a table of 4 last 2 digit actually keep on repeating, and that is the reason this rule was made. And it works for remainders as well. The bright thing is, remainders can also be found, right? Remainders. So how do you find remainders, guys? Simple. So I say what remainder when, what is the remainder when I say 39, 36, 47, 43 and 49 is divided by 4. So I have given you a very lengthy number, and this number is divided by 4. I know it is ending with 49, so it is not exactly divisible by 4. So now what is the remainder? So please divide only last 2 digits. That is 49 has to be divided by 4, 48, 1 remainder. So now this is good. It is working for remainders as well as for checking the divisibility, whether the number is actually divisible by 4 or not. Now I really remember a very good question on divisibility rule of 4. See, in permutations and combinations, many a times UPSC has given few numbers 1, 2, 3, 4, 5 and how many numbers, distinct numbers can be formed using these digits, right? But that is for permutations and combinations. So if I talk about topic like suppose I say I write a number like n, which is 1, 2, 3, 4, 5, 6. So if I say it in Hindi, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and so on, like goes on like this till 40th digit. Till 40th digit. Mind it, this might be a UPSC question. Till 40th digit. So what is the remainder when this number is divided by 4? Now generally students' perception is very simple, right? And yes, CSAT happens to be an amazing, awesome paper. And frankly telling you, most of you would make a mistake that this number ends with 40. And 40, when divided by 4, remainder is 0, right? But see guys, listen, count, right? So this is your first digit, second digit, third and fourth and fifth and sixth and seventh and eighth and ninth. So these were 9 digits. Your 10th digit is not 10. Your 10th digits, I'm changing the color of the pen, 10th digit is 1, 11th is 0, 12th is 1, 13th is 1, 14th is 1, 15th is 2, 16th is 1, 17th is 3. Are you getting it? So every double digit, 10 are 2 digits. So what is written? 40th digit. He is not going till 40th number. He is going till 40th digit. Alright. So this case, guys, come on. 40 digits. So 1 to 9, how many digits are written? 9 digits, right? And from 10 to 19, 10 to 19 are 10 digits, each digit having 2 digits, right? 10 to 19 are 10 numbers, each number having 2 digits. So it comes out to be, guys, 10 into 2, 20 digits. Come on, 20 digits. So if I'm writing a number 1, 2, 3, 4, 5, 6, 7, 8 and till 18 and 19. So frankly telling you, I have written 29 digits. I have written 29 digits. Alright, and then I need to go till 40th digit, isn't it? I need to go till 40th digit. So I think 20 to 24, 20, 21, 22, 23, 24 are 5 numbers, each number having 2 digits. So definitely 5 into 2, 10 digits. 5 into 2, 10 digits, which means now I can say it is 20, 21, 22, 23, 24. So obviously I've written 10 more digits. So when it ends with 24, this number is actually 29 plus 10, 39 digit number. 39 digit number. This number is 39 digit number, right? And then comes the last part. The last part is the 40th number. So after writing this, you know, see, this was 1 to 9, this was 1 to 9, and this is 10 to 19, and this was 20 to 24, right? So now I need to write one more digit. So 24 ke baad we get 25. So those 25 would have digit 2 only, because we need only one digit for 40 digits. So now I get, see, 29 digits, 10 digits and plus 1 digit is a 40 digit number, which means actually the number ends with 42. So this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it ends with 242. And when this number is divided by 40, divided by 4, remainder is 2. Remember this. I have given you a beautiful aspect for divisibility rule of 4. Alright guys, good. So this is a different version altogether, right? So then I say divisibility rule of 5, rule of 5. So a number is exactly divisible by 5 when it ends with 0 or a multiple of 5. Ends with 0 or a multiple of 5. Ends with a 0 or a multiple of 5. And guys, whenever you divide a number by 5, your possible remainders are 0, 1, 2, 3 and 4. So there are 5 remainders whenever you dividing a number by 5. Alright. So I think this might be the easiest thing to know, that a number when divided by 5 leaves remainder 0, 1, 2, 3, 4. And that number, exact multiple of 5, is easily recognizable. Because guys, come on, table of 5. 5, 10, 15, 20, 25, 30. So either ending with 5 or 0, ending with 5 or 0. Keep this simple logic in your mind. Alright. I hope this is clear to all of you. Clear. Great. Rule of 6. Divisibility rule of 6. I consider this to be really important, the divisibility rule of 6. And most of you actually know it as well, right? What is divisibility rule of 6? So it's actually 6 is what? Combination of two prime numbers, 2 and 3. So we say it is a rule of 2 and rule of 3 together, isn't it? So what is a multiple of 6? So I can say an even number whose sum of digits, an even number whose sum of digits is a multiple of 3 is a multiple of 6. So what is how do you look for a multiple of 6? 6 has to be even. A multiple of 6 has to be even. Just check out the table of 6. 6, 12, 18, 24, 30, 36, 42 and so on, all even numbers coming, and sum of the digits has to be a multiple of 3. Alright, this is really particular and both the rules go together. You just cannot have one single rule, right? Both go on together. So that is the reason I say rule of 2 and rule of 3. Rule of 2 and rule of 3. Keep this thing in mind, guys. Just make a note of it. Right? So now divisibility rule of 6 has to have a use, right? So I find it to be very useful, and you may be considering, sir, how do you find it to be useful? So I'm giving you a very simple explanation which will actually give you a lot of light otherwise also, and it would prove that how to use divisibility rule of 6. Now listen, I have a number n which is 347 into 499 into 513 into 649. Suppose this is the number given to you, and I say find remainder when n is divided by 6. Now when we were young, we would actually, I think we would multiply all the numbers and divide by 6. That is what it was. Today onwards, one thing you should always keep in mind: divide the individual numbers by 6 and find the remainders. First request to all of you is find individual remainders, dividing the number or all these 4 numbers individually by 6 and find remainders, right? And then when you divide, you don't need to do this 347 divided by 6. No, you don't need to do that. You don't need to do that, right? So divisibility rule of 3. So let's implement it now, right? So what is divisibility rule of 3, guys? Rule of 2 and rule of 3, Hana? So I say 347. A number less than 347 and a multiple of 6 is what we need to find, isn't it? Now 347 is not a multiple of 3, agreed? Divisibility rule of 3, if you check out, 3 plus 4 plus 7 is not a multiple of 3, right? So I say an even number, so 346. 346 is an even number less than 347, right? And now this is a multiple of 2. Is it a multiple of 3? No, sir. Then go to less. 3, 4, 4. 344 is a multiple of 2. Yes, sir. 344 is a multiple of 2. Do you think it's a multiple of 3? No, it is not. Then 342. 342 is a multiple of 2 and a multiple of 3. 3 plus 4 plus 2. 3 is a multiple of 3, 4 plus 2 is 6 is a multiple of 3. 342 is a multiple of 3. If you check the differences, 347 minus 342, remainder is 5. That is the use of divisibility rules. You know the rule, then you don't need to do division. Direct division nahi karna hai, you don't need to do it. You just check out this way, right? Sir, one more example. So let me give you this 499. Now 499 is not a multiple of 3 and it's an odd number, not a multiple of 2. So I say 498. A number less than 490 is 498. It's an even number. Now is this a multiple of 3? Yes, it is a multiple of 3. 4 plus 8 is 12, multiple of 3, 9 is a multiple of 3. Yes, it's a multiple of 3, which means what is the difference between these two? 1. So remainder is 1. That is the beauty of divisibility rules, right? 513. Now 5 plus 1 plus 3. 5 plus 1 plus 3 is a multiple of 3. So 513 is a multiple of 3, but it's a odd number. 3 less. 510. It's an even number and it's a multiple of 3. So remainder 3. Difference between them. So what I'm trying to find is, I'm trying to find a number which is less than a given number and it's a multiple of 6. Then I find the difference. I know that at the maximum, if you're dividing a number by 6, the maximum difference would be 5, right? Again, 649, 6 plus 4 plus 9, it's a odd number, it's not a multiple of 3, it's not a multiple of 2, so I say 6, 4, 8, it's an even number. Is it a multiple of 3? Yes sir. Remainder 1. So first thing, whenever you're given numbers in series or chain, so find individual remainders. I have written it, kindly write it properly. Alright, and then rather than multiplying these numbers, multiply the remainders. Whoa! So this comes out to be easy, multiply the remainders. So what is 5 into 1 into 3 into 1? 15. Guys, 15 when divided by 6, remainder is 3. Ooh, this is your answer. Keep this thing in mind. So simple, so easy, huh? Not at all tough. Not at all tough. I hope this is clear to all of you. So this is the exact thing we need to do when we are talking about divisibilities, right? So I hope when you join plus classes, you'll get more examples, right? So I'm coming up with plus course and you would be getting more examples of this, but I hope I'm clear with this, guys, right? And then comes the rule that is considered to be tough. So I today announce that this is one rule nobody knows. True, nobody knows. Whenever they say divisibility rule of 7, somebody like does that appending of the digits, and they keep on appending the digits, right? And they keep on reducing the digits from the right hand side, and this is what they do. But I'm frankly telling you, no, we don't require that. Divisibility rule of 2, today I'm making it easy. Today I'm giving you a guru mantra, right? So please pay attention. And yes, last to last year UPSC asked a question on divisibility rule of 7, which can be easily sorted out by this rule. So we are going to talk about that question as well. But before that, look at this divisibility rule of 7, right? So kindly remember this series: 1, minus 2, minus 3, minus 1, 2, 3. 1, minus 2, minus 3, minus 1, 2, 3, right? So you say, sir, why should we remember it? Because it is really important to check the number is divisible by 7 or not. For example, I say is 4949 a multiple of 7? And you know 4949 is a multiple of 7. I also know it is a multiple of 7. But if you want to use the series 1 minus 2 minus 3 minus 1 2 3, so kindly write 4949 starting from the left hand side, right? And 4, and then multiply. 4 ones are 4, and 9 into minus 2 is minus 18, and 4 into minus 3 is minus of 12, and 9 into minus 1 is minus of 9, which actually comes out to be minus of 35, right? If you add up, this is 18 and 12 is 30, minus 39 plus 4 is minus of 35. If over here in your answer you get a multiple, of 7 or 0, the number is exactly divisible by 7. Now I should not be writing 0 because 0 is a multiple of every number. But again, this is something you ought to know, right? So you may write 0 is a multiple of every number, because 0 can be written as 0 into 7, 0 can be written as 0 into 11, 0 can be written as 0 into 37. So 0 is a multiple of 7 also, 11 also, 13, 7 also. Alright. So now we get that 4949 is exactly divisible by 7. Sir, one more example: 1 minus 2 minus 3 minus 1 2 3 minus 1 2 3. So I say is 253 a multiple of 7? So either you would divide it this way, 253, but you cannot, so you write it below 253, right? 2 ones are 2, and 5 into minus 2 is minus 10, and 3 into 3 is minus of 9, and this is minus of 2, and this is plus 10, and this is plus 9. Your answer comes out to be 0. So again, when the answer comes out to be 0, this number is exactly divisible by 7. So now you have a rule where you can predict a given number is exactly divisible by 7 or not. But I know many of you would have a question in your mind that what if a number is having digits more than 6, right? In that case, dear students, giving you a beautiful rule today, right? The series is 1 minus 2 minus 3 minus 1 2 3 and 1 minus 2 minus 3 and minus 1 2 3 and 1 minus 2 minus 3 and minus 1 2 3. You can write it infinite times. It won't matter at all. All right, it won't matter at all, right? So keep this thing in your mind that this was something nobody knew before, and then UPSC put a question. But I'll show you the example also, don't worry, right? I'll show you the example as well. First of all, I hope this is clear to all of you, right? For example, if I have to check now, suppose I have to check, guys, suppose I get a number. Is this number 10000000000000001? Is this number divisible by 7 or not? Had you not known this rule, you could have actually solved it using this, isn't it? You could have solved it using this, divide by 7 and go the length and the breadth of the whole page, right? But now you know this. See, 1 ones are 1 and remaining all the factors would be 0, because a number multiplied by 0 would actually give you 0 till here, and there is minus 1, so you get 0 as a number, remainder with 0 as a result, which means this number is exactly divisible. This number is exactly divisible by 7. Kindly mark it, guys. This is something you may not get again, huh? This is something nobody knows. Clear? So I'll give you the question also. The question in UPSC, this is something important. He says the number 3798125 3798125 P369 is exactly divisible by 7. This is given to you, is exactly, yes, is divisible by 7. This is given. This number is divisible by 7. He says what could be the value of digit P? Options are 1, 6, 7 and 9. 1, 6, 7 and 9, right? So see, I have not seen any solution for this question anywhere, or anyone can give me a solution better than what I'm giving you today. This is a UPSC question and I'll do it my way. I'll write the rules, right? I say 1 minus 2 minus 3 minus 1 2 3 1 minus 2 minus 3 minus 1 2 3, right? So I have written the numbers that I want. It's an 11 digit number. So 1 minus 2 minus 3 minus 1 2 3 1 minus 2 minus 3 minus 1 and 2. So I multiply, this gives me 3 ones are 3, and this is minus of 14, right? And this is minus of 27, this is minus of 8, this is plus of 2, plus of 6, plus of 5, minus 2p, minus 9, minus 6 and plus 18. This is what you get, right? This is what you get when you are 3798. Yes, this is what exactly we get. And then you just need to add up this, guys. Minus 14 and minus of 27 is minus of 41, minus of 41 minus 8 is minus of 49, minus of 49 minus 9 is minus of 58, minus of 58 minus 6 comes out to be minus of 64. So I've written all the negative numbers together. Then plus 3 plus 2, 3 plus 2 is 5, 5 plus 6 is 5 plus 5 is 10, 16, and 16 plus 18 comes out to be 34. And then this is minus 2p, right, which comes out to be minus 30 minus 2p. This is what I get. Now this number has to be exactly divisible by 7. If the whole number is exactly divisible by 7, isn't it? The number given is exactly divisible by 7. So I just start putting the values of p. See, this is what UPSC wants. If I say p is equal to 1, this gives me minus 30 minus 2, which is minus of 32, not a multiple of 7, wrong. If I put p is equal to 2, then I get minus of 30 minus of 30, and see, I put p is equal to 6 here, option, this is p is equal to 6, minus of 30 and minus of 12, which is minus of 42, which is exactly divisible by 7. So p is equal to 6 is your answer. Anyone who can give me a better idea to solve this question, I would love it. I welcome you all for the same, guys. I wish I have made some difference. I wish you have understood the topic. Let's just close it for today. So guys, please, this is something really amazing. 57 out of 79 questions in UPSC CSE GS mains were from our test series. The Last Mile UPSC CSE free interview guidance program is on. So we have the key points. You can make a note of it. Also, please make Unacademy Civil Services Championship your next goal. Top 50% of the participants to win guaranteed Unacademy scholarships. Alright. And 50 MCQ, 60 minutes. November 13th is the day. So guys, with that, thank you so much. I hope you have enjoyed my class, and I see you next class. Till then, Jai Hind.